View the switch MAC address table. This topology: Cisco switch 2960 S1 and another switch 2960 S2, and devices 2 PCs, PC-A and PC-B. Use the straight-through cable to connect fast Ethernet 6 to PCA and on S2 fast Ethernet 18 to PCB. And finally, the connection between switches using fast Ethernet in both sides. This is the addressing table. Okay, S1 on interface VLAN 1, the IP address 1.11, subnet mask 255.255.255.0. S2 also on VLAN 1, IP address 1.12, subnet mask the same, PCA, network interface card, IP address 1.1, same subnet mask, and PCB, network interface card, IP address 1.2, and same subnet mask. The purpose of Layer 2 LAN switch is to deliver Ethernet frames to host devices on the local network. The switch records host MAC addresses that are visible on the network and maps those MAC addresses to its own Ethernet switch ports. This process is called building the MAC address table. When a switch receives a frame from a PC, it examines the frame source and destination MAC addresses. The source MAC address is recorded and mapped to the switch port from which it arrived. Then the destination MAC address is looked up in the MAC address table. If the destination MAC address is a known address, then the frame is forwarded out of the corresponding switch port associated with that MAC address. If the MAC address is unknown, the frame is broadcasted off all switch ports except the one from which it came. It is important to observe and understand the function of a switch and how it delivers the data on the network. The way a switch operates has implications for the network administrators, whose job it is to ensure secure and consistent network communication. Make sure that the switches have been erased and have no startup configurations. If you are unsure, contact your instructor. Required resources: 2 switches, Cisco 2960, 2 PCs with Windows and Teraterm, console cables, Ethernet cables. In my case, I'm using Packet Tracer. The fast Ethernet interfaces on Cisco 2960 switches are auto-sensing, and an Ethernet straight-through cable may be used between switches S1 and S2. If using another model Cisco switch, it may be necessary to use an Ethernet crossover cable. Build and configure the network. Cable the network according to the topology already completed on Packet Tracer. Configure PC hosts. Use the addressing table to configure PCA and PCB. PCA 192.168.1.1. Subnet mask 255.255.255.0. No default gateway, no DNS, PCB. IP address 192.168.1.2. Same subnet mask. Ready. Initialize and reload switches as necessary. Okay, as an example, console from PCI RS-232 port to console port on switch S1, and on PCI use the terminal. Then okay, enter. Okay, for example, if the switch has previous configurations, you can erase the contents of the switch using the following command. Use the enable command to access the privilege exit mode. Okay, now you are on privilege exit mode. Then use the following command: erase startup -config. Enter to confirm, and delete VLAN.dat. Okay, delete the VLAN database. Enter to confirm. Again, reload the switch. Okay, this is the example to erase the contents if the switch has previous configurations. Okay, do this also on S2 if S2 has previous configurations. Okay, enter. How you can verify if the switch has no previous configurations? Just show running config. This command is not permitted on user exit mode, so use the enable command to access the privilege exit mode, and use the show running config. Now you can see all configurations. Press space. Okay, no configurations on interfaces, no IP on VLAN, on VLAN 1, no IP, and is shut down, and no configurations on lines. So now you can see there are no configurations. Okay, configure basic settings for each switch. Okay, configure device name. Access to global configuration mode with the configure terminal command. Okay, now you are on global configuration mode, and set the host name according the topology. This is S1. Okay, host name S1. Configure IP address as listed in the addressing table. Okay, on S1, on VLAN 1, 1.11, subnet mask 255.255.255.0. Okay, interface VLAN 1, configure the IP address 192.168.1.11, subnet mask, and enable the interface with the no shutdown command. Okay, assign Cisco as the console and BTY passwords. Okay, you are in the interface configuration mode. Now exit to go the global configuration mode and set the password for console and BTY. First of all, on console, and you need to access the line configuration mode with the following command: line console 0, because there is only one console, 0. Okay, now you are in the line configuration mode and set the password Cisco. Enter, and enable the password using the login command. Now configure on BTY. You can use the exit command to go from the line configuration mode to global configuration mode. But anyway, you can go directly from line console to line BTY. For example, from 0 to 15 uh, lines. From 0 to 15, there are 16 lines. Then enter, then use the password Cisco and enable with the login command. Okay, enable the password. Now assign class as the privilege exit password and use the exit command to go from line configuration mode to global configuration mode and set the privilege exit password. Okay, enable secret class. Okay, this is the password class for enable command. Okay, enter and ready. Okay, do this on S2. From PCB, connect to RS-232. Go to console and use the terminal. Okay, then configure the switch S2. Enter and verify the switch is erased. There are no previous configurations. Start to configure this. Enable to access the privilege exit mode. Configure terminal to access the global configuration mode. Device name, host name S2, and set the IP address. Interface. Review the addressing table on VLAN 1, this IP address and subnet mask. Interface VLAN 1 IP address 182.168.168.112. Subnet mask and no shutdown to enable the interface. Okay. Now configure the passwords. Exit from interface configuration mode. Exit on global configuration mode. Go to line console 0. The password is Cisco. Enable the password with login. Go to you can exit from line configuration mode and go to global configuration mode. The access line BTY 0 to 15 lines. Set the password also Cisco and login. Exit on global configuration mode. Set the enable secret password that is class in this case. Then ready. Now examine the switch MAC address table. A switch learns MAC addresses and builds a MAC address table as network devices initiate communication on the network. A record network device MAC address. Open a command prompt on PCA and PCB and type ipconfig hole. What are the Ethernet adapter for physical addresses? Okay, on PCB, close the terminal and go to command prompt. Verify the MAC address with ipconfig space / all command space, and this is the MAC address. Okay, but this is for PCB. For PCB. Okay, this is the MAC address. On PCA, close the terminal, go to command prompt, ipconfig space / all space. This is the MAC address. Ready. Console into switch S1 and S2 and type the show interface Ethernet 1 command in each switch. Okay, PCA is connected using a console cable to S1. So access the S1 using the terminal and use show interface Ethernet 1. But you should insert this command on privilege exit mode. Use the exit command to go for global configuration mode to privilege exit mode, and just here use the show interface Ethernet 1 command. Okay, remember Ethernet is the interface connected to the another switch. Okay, enter space. This is the result. Also on switch S2, PCB is connected to the console of switch 2. PCB, close the command prompt, go to terminal to access the console of S2, exit from global configuration mode, and on privilege exit mode, use the show interface Ethernet 1 command. On the second line of the command output, what is the hardware address or boardnet in address BIA S1 Ethernet 1 MAC address. Okay, S1 PCA. Okay, S1 this line. This is the same. Okay, PCB this. Okay. Okay, they are different. Also, MAC addresses on PCA and PCB, they are different. Display the switch MAC address table. Console into switch S2 and view the MAC address table, both before and after running network communication test with ping. Okay, switch 2 is connected to PCB using console, then use the establish a console connection to S2 and enter privilege exit mode. Okay, this connection is already completed between PCB and S2 using the console cable. In privilege exit mode, type the show MAC address table and press enter. Okay, on S2 on the terminal, show MAC address table. Okay. Even though there has been no network communication initiated across the network, no use of ping, it is possible that the switch has learned MAC addresses from its connection to the PC and the other switch. Are there any MAC addresses recorded in the MAC address table? Okay, I have only one line. This is the Ethernet 1. This is the Ethernet 1 port. This port on switch 2. Ethernet 1 is connected to S1. And review this MAC address 0002 16476201. Review this. The switch 1 Ethernet 01 MAC address is 0002 16476201. This MAC address. So S2 on Ethernet 1 can learn the MAC address of Ethernet 1 of S1. and is this MAC address, and is associated with Fast Ethernet 1 port on S2. The switch may have one or more MAC addresses in its table based on whether or not the students entered a ping command when configuring the network. The switch will most likely have learned MAC addresses through S1's Fast Ethernet 1 switch port. The switch will record multiple MAC addresses of hosts learned through the connection to the other switch on Fast Ethernet 1. What MAC addresses are recorded in the table? To which switch ports are they mapped and to which devices do they belong? Ignore MAC addresses that are mapped to the CPU. There may be multiple MAC addresses recorded in the MAC address table, especially MAC addresses learned through the S1's Fast Ethernet 1 switch port. In the example, the S1 Fast Ethernet 1 MAC address is mapped to S2 Fast Ethernet 1. Okay, S1 Fast Ethernet 1 MAC address is mapped to S2 Fast Ethernet 1. If you had not previously recorded MAC addresses on the network devices in step 1, how could you tell which devices the MAC addresses belong to? Using only the output from the show MAC address table command, does it work in all scenarios? The output of the show MAC address table command shows the port that the MAC address was learned on. In most cases, this would identify which network device the MAC address belongs to, except in the case of multiple MAC addresses associated to the same port. This happens when the switches are connected to other switches and record all the MAC addresses for devices connected to the other switch. Clear the S2 MAC address table and display the MAC address table again. In privileged exit mode, type clear MAC address table dynamic and press enter. Okay, clear MAC address dash table dynamic, enter. Quickly type show MAC address table again, enter. Does the MAC address table have any addresses in it for VLAN 1? Are there other MAC addresses listed? No. You will discover that the MAC address for the other switch, Fast Ethernet 1 switch port, has been quickly reinserted in the MAC address table. Okay, remember this is the MAC address. Remember you are on switch 2 here, and this is the MAC address of Fast Ethernet 1 of switch 1, S1. Is learned on port Fast Ethernet 1 on S2. Wait 10 seconds, type the show MAC address table command and press enter. Are there new addresses in the MAC address table? Okay, wait at least 10 seconds, then repeat show MAC address table command on S2. The same line present. There may be more MAC addresses in the table, maybe the MAC address of PCA. From PCB, ping the devices on the network and observe the switch MAC address table. From PCB, open a command prompt and type ARP option A. Okay, go to PCB. Okay, this is PCB. Close the terminal. Open command prompt. Review the MAC address table using ARP option A. And no entries found. not including multicast or broadcast addresses. How many device IP to MAC addresses pairs have been learned by ARP? Okay, the ARP cache may have no entries in it, or it may have the gateway IP address to MAC address mapping. From PCB command prompt ping PCA S1 and S2. Okay. First of all, ping to PCA. PCA is close the terminal on PCA and go to command prompt to review this IP of PCA 1.1. So go back to PCB, then ping PCA 192.168.1.1. Enter success. Ping S1. Remember, S1 on the addressing table was configured with 1.11 and S2 1.12. Okay, PCA, ping from PCB to 1.11, that is S1. Success, ping 1.12, ping 1.12, enter. Success. Did all devices have successful replays? If not, check your cable and IP configurations. Okay, if the network was cabled and configured correctly, the answer should be yes in all cases. Okay, success in all cases. From a console connection to S2, enter show MAC address table command. Okay, and close the command prompt, go to terminal that is connected to S2. Connected to S2, show MAC address table, enter. Now you have at least 4 lines, okay, with the type dynamic. 3 learned on Fast Ethernet 1 and 1 learned on Fast Ethernet 18. Okay, and go back here and look at this. Okay, this MAC address 002.16476.6201 is learned on Fast Ethernet 1, and this MAC is the MAC address of Fast Ethernet 1 on S1. Okay, 002.164.7.6201. This MAC address, Fast Ethernet 1 on S1. Also this MAC 0030F2516BB2 is learned on Fast Ethernet 1 and is this the MAC address of PCI 0030F2516BB2, the MAC address of PCI. And this MAC address 0002.1783C071 is learned on Fast Ethernet 18 on this interface on Fast Ethernet 18. And this is the MAC address of PCB. The MAC address of PCB. Okay, this 0002.1783C071. And finally, an additional MAC address 00E0F7182320. Try to find this MAC address. For example, from PCA, access the console connection to S1 using terminal. And use the command enter and password Cisco enable command password class. Now you are in privilege exit mode and just show interface VLAN1. And now you have this address 00E0 F7182320 is the MAC address of VLAN1 on S1. Okay, go to PCB 00E0 F7182320. This is the MAC address of VLAN1 on S1. Because from PCB the pings were made to S2 on VLAN1, S1 on VLAN1 PCA. Did all devices have successful replays? If not, check your cabling and IP configurations. Has the switch added additional MAC addresses to the MAC address table? If so, which addresses and devices? There may only be one additional MAC addresses mapping added to the table, most likely the MAC address of PCA. There are additional MAC addresses mapping added to the table. For example, the MAC address of Fast Ethernet 1 on S1, the MAC address of PCB, the MAC address of PCA, and the MAC address of VLAN1 on S1. From PCB, open command prompt and retype ARP option A. And go to command prompt, ARP option A. Now you have 3 lines. The MAC address of PCA with its IP address, the MAC address of VLAN1 on S1 with the IP address and MAC address of VLAN1 on S2 with the IP address. Does the PCB ARP cache have additional entries for all network devices that were sent pings? Yes, at least 3 additional lines with the IP addresses and MAC addresses. On Ethernet networks, data is delivered to devices by their MAC addresses. For this to happen, switches and PCs dynamically build ARP cache and MAC addresses tables. With only a few computers on the network, this process seems fairly easy. What might be some of the challenges on larger networks? ARP broadcasts could cause broadcast storms because ARP and switch MAC tables do not authenticate or validate the IP addresses to MAC addresses. It would be easy to spoof a device on the network. Thank you.